This is a short review we'll be doing for the test. Here's some of the topics that will be covered on this test. There's quite a few. I've given examples of every type of question that's on the test if you'll watch this review. If you don't watch this review, I guarantee you won't do well on the test. This is going to be a little bit tough because it's stuff we've done a while ago, and you need to have done both of the ALEKS assignments on absolute values and solving quadratics in order to do this test well. Okay, so we're going to be covering completing the square, square root method, word problems with irrational roots, multiplying complex numbers, simplifying a power of I, solving a quadratic equation with complex roots, applying the quadratic formula with exact answers, translating the graph of absolute values in 2 steps, graphs of a absolute value of x, graphs of absolute value equations that are more advanced where you have a shift right, left, and up and down, and graphing a piecewise function that is very simple. So we're going to be doing all that stuff. So let's start here at the first one. This is just a simple solving by using a square root method. So here we have x plus 3 squared minus 5 equals 0. The key here is that the x plus 3 squared is already in a parenthesis squared. This is the key to knowing when you're going to use the square root method. Okay, so to use the square root method, all I got to do is get that parenthesis squared by itself. So I'm just going to add 5 to both sides. That gives me x plus 3 squared equals 15. And I'm going to take the square to both sides. Now when you do this, you have to do plus or minus square root of 15. So I'm going to say that x plus 3 equals the positive square root of 15, or I'm going to say that x plus 3 equals the negative square root of 15. Now, I think on this one it's going to ask for a decimal answer. If it asks for an exact answer, it's really easy. I just subtract 3 from each side, and that's my 2 answers. So I'm going to have negative 3 plus the square root of 15, negative 3 minus the square root of 15. If it wants that as a decimal, all you got to do is take the square root of 15 and round it to the nearest hundredth, I think is what it will say. So I'm going to do that on the calculator over here. It's square root of 15, and that's 3.87. So this is 3.87, and that's going to give you negative 3 plus 3.87. This is going to equal 0.87. And negative 3 minus 3.87, negative 3 minus 3 more 0.87 is going to give you negative 6.87. Okay, so those are your 2 answers on that one. Fairly easy. Okay, over here we're going to have a completing the square. So this one's going to say x squared plus 10x plus what will actually complete the square. So to complete the square, you may have forgotten, but it's not that complicated. You take half of this linear term, square that value, and it will be this value. So let me say that again. You're going to take half of this term's coefficient. If it was a negative, you would take half of that. But when you square it, it's always going to be positive. So this will always be a positive value. So if I take half of 10, that's going to be 5. I'm going to square that value. That's why it becomes a perfect square trinomial. And that's why we're completing the squares, to make this whole equation be a perfect square trinomial. So I want this to be a perfect square. Well, 5 squared is a perfect square, obviously. That's going to be 25. So the answer here is 25. That's what will go in the box when you see it on ALEKS. Next type of question will be right here. It'll be solved using the quadratic formula. Now, if you need to, you can review the quadratic formula song on YouTube. Quadratic formula is very simple though. It's just negative b plus or minus the square root of b squared minus 4ac all over 2a. So you need to identify which values for each of these variables in the quadratic formula are coming from this equation. Most important is you need to set this equal to 0 to begin with. Once it's equal to 0, it's not that difficult because this is your a value, the number in front of the square. This is your b value, the number in front of the x. And this is your c value, the number with no x at all. So it's important to write it in descending order. The other thing that's nice to make sure you do is make sure this value, that is the first value, is positive. That's very key. Again, make sure this a value is positive. Doesn't matter what these other two are, but this one needs to be positive. All right, now we're going to do the quadratic formula here. Very simple again. Do it off to the side here. We're going to go -9, because that's the opposite of the b value. A lot of kids who miss that one simple little thing, which is to go opposite sign on that b value. Plus or minus square root of b squared, so I'm going to take 9 squared, that's 81, minus 4 times, so that -4 is a constant. It doesn't change. Notice there's not a 4 in this equation here, but there is a -4 in the quadratic formula, and it's always there. So this is -4 times a, the a value is 6, times c, the c value is 2, all over 2a. So I got to take 2 times 6. Again, a lot of kids just want to write a 2 here every time. It's 2 times the a value, so this is actually 12. Okay, and now we're going to do that. I think on this one it's going to ask for an exact value, or it could be asking for a decimal, and I'll do both of those. So now I just do the math here. I do 4 times 6 times 2. Well, 4 times 2 is 8. 8 times 6 is 48. So this is minus 48. I do that on my calculator. I do 81 minus 48. And I get 33. So I'm going to have -9 plus or minus the square root of 33 over 12. And if it wants exact form, that's it. I'm done. Okay. And I'll put it into Alex just like that if it asks for exact form. If it wants decimal values, now I've got to actually do the square root of 33. Now you can semi-guess that, but because it's not quite 6, so it's going to be like 5.8. But instead of guessing it, you might as well just do it on your calculator. Just do square root of 33. And this says 5.74, so that tells you I was way off there, as usual. 5.74 is that value. So now I do -9 plus 5.74. -9 plus 5.74 is -3.26. Now, a lot of kids are going to put that as their answer. Make sure you divide it by 12. And that would be -2 point, well, where are we at? Okay, sorry. -0.27. So -0.27 is one of the answers. The other thing that I want to do is I want to do -9 minus 5.47. So -9 minus 5.74, sorry, 5.74. And that's going to give me -14.74. And I'm going to divide that by 12. So this is going to give me -1.23. So my other answer is -1.23. So those are the 2 points that it actually crosses the x-axis if we were to graph that. It would cross the x-axis at -0.27 and -1.23. Okay? Next, we're going to have a very similar question, but it's going to have quite a different answer. We're going to solve this using the quadratic formula, but this one actually won't cross the x-axis, so we're going to end up with imaginary roots. So as we do this, if you end up with a negative under the square root, that's called the discriminant, you're going to end up with a I value because it's an imaginary value, because the graph actually never crosses the x-axis like the other one did. So this one will not cross the x-axis, and therefore we'll have imaginary roots. But we're still going to just use the quadratic formula. It's not that big a deal. So I'm going to take -4 plus or minus square root of 4 squared, which is 16, minus 4a, a value is 3, c value is 8, all divided by 2a. So now I have to take 4 times 3 times 8. Well, 4 times 3 is 12. 12 times 8 is 96. So I'm going to take 16 minus 96. And that's going to give me -80. So I've got -4 plus or minus square root of -80 all over, oh, sorry, I wrote 2a. 2 times 3, which is 6, all over 6. Okay, now, because that's a -80, I've got to just simplify that. So this is going to ask for simplified square root form. It's not going to ask for a decimal value because there is no decimal value, because the square root of a negative has to be an I value. So what I'm going to do is I'm going to simplify this 80. I'm going to factor tree that down. 8 and 10. 8 is 3 2's, 2, 2, 2, and 10 is a 2 and a 5. So I've got a pair of 2's and a pair of 2's. So when I bring those out, that's going to be a 2 times another 2. For every pair, you bring one out. 2 times 2 is 4. So I end up with -4 plus or minus 4i. Now the I came from that being negative. Anytime you have a square root of a negative, it's going to come out as an I. You really can't take the square root of a negative. So it's an imaginary value. So I bring out that I value every time there's a square root of a negative. So I factor tree down, I got the 4i, and there's still this 5 left. So I have to do a square root of 5 on top. So that's actually my answer right there. I'm going to write -4 plus or minus 4i square roots of 5 over 6. Now the one thing that it will do is reduce, so I want to reduce all of these. 2 will go into every one of those values. You can't reduce under the root, but you can reduce outside of the root if they have a common factor. So notice 2 goes into 4, 2 goes into 4, 2 goes into 6. So I'm going to reduce all those by dividing by 2. So I end up with -2, 4 divided by 2, plus or minus 2i, again 4 divided by 2, roots of 5 all over 6 divided by 2 is 3. That's my final answer. All right, next one says find, sorry, kind of all over the place here. I'm trying to do this on my own. Find all values where the height of a, oh, sorry. So this is a story problem that's on there. A ball is hit from a height of 4 feet with a velocity of 31 feet per second. I want to know all values where the height of the ball is 12 feet. This is the hardest question on the test. So first of all, I got to set up my equation. Remember, gravity is -16 feet per second. So I'm going to go squared, sorry. -16 t squared, that's the time squared. That's always gravity. That's always going to lead this type of a story problem equation. Anytime you have the height of a ball being hit, thrown, a cannon being fired, it doesn't matter. Anytime you're going to have a ball going up in the air, you're going to have gravity working against it, which is -16 t squared. Your velocity is going to be your coefficient for your linear value in front of the t. So I'm going to put plus 31t. Okay, then my last value is the initial height. Well, this was hit from a height of 4 feet. So I'm going to put plus 4 equals, now it equals, usually it equals y squared, and usually I solve for the zeros when it hits the ground or something like that. But in this case, it says, hey, I want to know when the height was 12 feet above the ground. So I'm going to set this equal to that height. That is super important. So when it wants to know all values, so this is key on Alex, all values when the height of the ball is 12 feet, you take your written equation and you replace the y value or f of t value with 12, because that's the height after t seconds will be 12. So there's an h of t value there, or some people just call it the y value because the y-axis is representing the height. And we're going to just set that equal to 12. Okay, now I got to get this equation in quadratic form where I can solve it with the quadratic formula. So I'm going to first bring over the 12, just minusing 12 to both sides. That's going to give me negative 16t squared plus 31t minus 8 equals 0. Now the only thing here is I don't want this to be negative. Do not leave the quadratic term negative. Divide every single term by a negative 1. Or you can think of it as multiplying through a negative 1. I don't care. If you multiply every single term by a negative 1 or you divide every term by a negative 1, it's the same. And you'll end up with 16t squared minus 31t plus 8 equals 0. Now the reason you want to do that is the quadratic formula works much better when that a value is positive. It just makes your quadratic formula work better. So always try and make that a value positive before you solve. I'm going to say that one more time. Make that a value positive before you solve, especially on these story problems that will always start out with that negative 16t squared. Okay, just by dividing or timesing by a negative 1. All right, now we're going to do the quadratic formula. So I just take opposite of negative 31, which is positive 31, plus or minus 31 squared. I don't know what that is, so I'm going to do it on my calculator. I'm going to hit 31 squared. 961. So that was 31 squared. Minus 4ac. So I'm going to write it small up here, and then I'm going to write it down so I don't run out of paper. 4a value is 16. See how that's positive now? And then c value is 8. So I'm taking negative 4 times 16 times 8. So let's see what that gives me. 4 times 16 times 8. That's going to give me negative 512. So now I do 961 minus 512 is 449. So I have 31 plus or minus square root of 449. Oh, sorry, 449, sorry. All over, and then we do 2a. So that's 2 times 16 is 32. Okay, so we want some amount of time. So this is definitely going to be a decimal value. So I just got to do the square root of 449. So I'm going to hit square root of 449. And that gives me 21.2. Okay, rounded to the nearest tenth. So this is 21. This is equal to 21.2. So now I'm going to take 31 plus 21.2 divided by 32. So I'm going to do that. 21.2 plus 31 divided by, oh, I hit equals first, then divided by 32. That gives me 1.63 seconds. So 1.63 seconds after I hit that ball, it's going to be at 10 feet. Or sorry, that's going to be at 12 feet. Now that's on the way down. On the way up, it's going to be the 31 minus 21.2 divided by 32. So I'm going to do that on my calculator. 31 minus, because notice it's plus or minus there, 21.2 equals, that gives me 9.8 divided by 32. That's going to be 0.3 seconds. So on the way up, it's going to take 0.3 seconds after I hit the ball. And you got to think about that. I'm hitting it from a height of 4 feet initially. It's not going to take that long to get up to 12 feet if I'm hitting it at 31 feet per second. I'm going to hit it at 0.3 seconds. It's going to hit that 12-foot height. And then on the way down, about 1.63 seconds after I've hit the ball, it's going to come back down at 12 feet high. So it'll be 12 feet in the air, both at 0.3 seconds and at 1.63 seconds. That's the hardest question on the test. So make sure you rewind this video and rewatch that in order to make sure you know how to do that question. Make sure your negative 16t squared becomes positive by dividing or multiplying by a negative. That's going to be key to this question. All right, next ones are going to be pretty easy and we'll zip through them. I to the 63, all you got to do is divide 63 by 4 to simplify that. So 63 divided by 4. Don't do it on a calculator. If you do it on a calculator, it's going to give you some decimal, and that isn't what you want. You want the remainder here. So think about 4 going into 6, just doing an old school long division. 4 going into 6 goes once, because 1 times 4 will give you a 4. That's smaller than 6, but not going over, so I'm going to subtract that. It's going to give me 23, dropping down the 3. And then I just do 4 into 23. So what times is by 4 and is a little bit less than 23 without going over? Well, that's going to be a 5. So that's going to be 4 into 23. 4 times 5 is 20. Subtract those, and we end up with a 3 remainder. This remainder is key, okay, because that sets up our I chart. Remember, I, if you end up with an I to the first, it's going to be I. And I to the second is going to be -1. An I to the third is going to be -I. And an I to the fourth will be actually a 0. Well, you're going to end up with a 0 here. So when you do this long division, if you end up with a 0 value, you're going to end up with a 1 there. Okay, so this is remainder of 0. This is remainder of 3. This is remainder of 2. This is remainder of 1. Okay, so those are your values on this one. So I to the 63rd really is going to be the same as I to the third because of the remainder being 3. So therefore the answer on this one is -I. The answer will always be one of these 4. It'll either be I, -1, -I, or 1. If the remainder, after you divide that exponent by 4, if the remainder is 1, it'll be I. If the remainder is 2, after you divide by 4, you always divide by 4 because this is a pattern of 4. So there's only 4 possible values there. So I'm going to divide, if I divide this and I get a remainder of 2 here, then that would have gone to -1. If you get a remainder of 3 like we did here, we end up with -I. And if we end up with a remainder of 0, meaning 4 goes into the number perfectly, then we're going to end up with 1 as our answer. The next one is just multiplying imaginary numbers. Now remember, I squared, as we saw over here, is -1. So you just have to remember that as you multiply. So we're just going to FOIL this, timesing the first terms, -12, timesing the outside terms. Negative times negative is a positive 15i. Timesing the inside terms, 4 times 2 is 8i. And then timesing the last terms. This is where you got to watch it, because a 2 times a -5 is a -10, but you have I times I, which is I squared. And every time you square, so you got to quit your squaring, but every time you square, you're the -1. So don't be the -1, quit your squaring. So I squared is -1. That's how you can remember that. So I squared is -1, and -1 times a -10 is a +10. Now you just combine like terms. -12 plus 10, -2. 15i plus 8i is going to end up being 23i. These are just adding. So I'm just going to take -3 plus 4. That's really simple. 1. You just add the like terms. Now I add the i's. 2i minus 5i is -3i. That's my answer. So anytime you're adding, it's simple. Pay attention to whether there's a plus between or whether there's a multiply between. If there's a multiply between, you got to do this FOIL method and remember your I squared. If you're doing adding, you won't have an I squared. You'll just simply add. Okay? Last few that are graphing. We're going to graph this absolute value of x minus 3 plus 5. You just got to remember how this shifts. The outside shifts up and down. The inside shifts opposite along the x-axis. So instead of going to the left 3, we go opposite right 3. So I'm going to shift this right 3 and up 5 for my vertex. So I'm going to go right 3 and up 5. So there's my vertex. Now if the number in front is negative, it'll open down. In this case it's not, it's positive, so it'll open up. And it's going to follow unless there's an a value in front of there, which we'll talk about in a second. Unless there's a number in front of that, it just goes over 1 up 1, over 1 up 1 to the left, over 1 up 1 to the, or over 2 up 2 to the right, over 2 up 2 to the left. You end up with a V-looking graph. Every absolute value equation is going to be a V graph. Over 1 up 1, over 2 up 2, over 1 up 1, over 2 up 2 on the standard graph. That's if the a value is 1, meaning there's no number in front of the absolute value. Looking at the next one, you have a negative 3 in front of the x. Now that means it didn't shift right or left because there's nothing being added to inside of the absolute value. And it didn't shift up or down. There's nothing being added out here to the side, added or subtracted. So I'm going to simply mark 0, 0 as my starting point. The key is we have an a value now that is negative 3. So that says we're going to open down, and it's 3 times steep. So I'm going to go to the right 1, and instead of going down 1, I got to go 1 times 3, which is 3. I'm going to go down 3. To the left 1, down 3. Normally I would go 2, 2. 2 times 3 is 6. So I'd go over 2, and I'm going to go down 3, 4, 5, 6. Down 6. Same thing here, negative 2, down 6 from this vertex point, and I come down. It's quite a bit steeper, you'll notice, than this one. This one's wider, this one's steeper. Okay, and it opened down because of the negative in front. Okay, the last one is our piecewise function. The key to piecewise functions are right here, the parameters. Okay, so as I set up my graph here, I've got to think, okay, negative 2 is going to be a key point, and 2 is going to be a key point. Why negative 2 and 2? Well, that's the parameters. Negative 2 on the x-axis and 2 on the x-axis. Those are my key points. All right, now if I go left of negative 2, y will always be 3. So I say, okay, y is always 3 when I'm left of negative 2. So I'm going to mark that point at 3. That's where I got the 3 from. And I'm going to go just, if the y value is always 3, it has to stay on a horizontal line at 3. So I'm going to draw that line out like that. Now the key here is this point. If it's equal to, I fill it in. If it's not equal to, I'm going to put a circle around it, which is what I'm going to do on this one. Okay, the next one says, in between negative 2 and 2, the graph is y equals x. What the heck does that mean? Well, that means that x's and y's will always match. So if you put in a negative 2 for x, what will y be? Negative 2. So I'm going to go to negative 2 on the x, down 2 on the y. That's my starting point. If I go negative 1, I'm going to go to negative 1. It's always going to match. If I go to 0, 0, if I go to 1, 1, if I go to 2, 2. Now these endpoints have to be circled through that line. And the reason they have to be circled is because they're not equal to. The last part is going to say, all right, now if x is greater than or equal to 2, the y value will always be negative 2. So I think about that. Okay, I'm going to come down to negative 2. I'm going to go over here. Always it's going to be negative 2. So that's, again, a horizontal line at negative 2. And there's how my graph looks. This is your general piecewise function. Thanks for joining me. I hope you are able to do really well on this test. Do view this video before you take it. Thanks. Bye.